2026, above the sky of Barcelona, a gigantic crane slowly lifted a star onto the top of the Virgin Mary Tower of the Sagrada Familia. When this piece was secured in place, the structure officially became the tallest church in the world after 144 years of construction. The Sagrada Familia was begun in 1882 by the genius architect Antoni Gaudí. But this is not simply a church. It is a colossal architectural project that has stretched across many generations. For more than a century, the structure has survived 2 world wars, a civil war that destroyed all of the original design drawings, and a global pandemic that forced construction to stop. So what has allowed a structure that seemed destined to be erased by history many times to ultimately rise again and move closer to the finish line? The story of the Sagrada Familia began in the late 19th century, when a group of Catholics in Barcelona decided to build an expiatory church funded by donations from the public. Initially, the structure was designed in a traditional Gothic style. However, everything changed when the young architect Antoni Gaudí took over the project in 1883. Gaudí quickly transformed the structure into a bold architectural experiment. He drew inspiration from nature to create stone columns resembling tree trunks, vaults curved according to natural geometry, and towers rising like rocky mountains. Instead of relying entirely on drawings, Gaudí used plaster models and hanging chain models to calculate structural forces. When Gaudí died in 1926, less than 1/4 of the church had been completed. After that, the project went through many historical upheavals. During the Spanish Civil War, Gaudí's workshop was destroyed and most of the design models were smashed. From the remaining fragments, later generations of architects gradually reconstructed Gaudí's vision. This challenging process of restoration has turned the Sagrada Familia into one of the longest-running and most extraordinary architectural projects in history. And by the year 2026, the structure is still moving closer to completion after more than a century of construction. The design of the Sagrada Familia is unlike any church ever built before. While traditional Gothic architecture relies on thick walls and external support systems, Gaudí envisioned a structure in which the entire load is transferred through internal stone columns, like tree trunks in a forest. The entire basilica is organized around 18 towers, each carrying its own religious meaning. 12 lower towers represent the 12 apostles, 4 taller towers symbolize the 4 evangelists. 1 tower is dedicated to the Virgin Mary, and the tallest central tower is dedicated to Jesus Christ. When completed, this central tower will reach a height of 172 meters, making the Sagrada Familia the tallest church in the world. However, Gaudí deliberately designed this height to be exactly 1 meter lower than Montjuic Hill because he believed that human creations should not surpass what nature and God have created. Inside the church, the columns are not straight as usual. They twist as they rise and branch out near the ceiling, like tree trunks dividing into multiple limbs. Thanks to this design, the entire vault can be supported without the need for massive walls, creating a vast, open space filled with natural light. The primary material of the Sagrada Familia is natural stone. Initially, Gaudí used Montjuic stone, but today it has been replaced with similar types of stone sourced from quarries around the world due to the depletion of the original source. All stone is carefully extracted and rigorously tested for durability to ensure the structure can last for centuries. These stone blocks do not only form the walls or columns of the basilica. A large portion of them is used for a special structure located at the very center of the building, the Tower of Jesus Christ, the most important tower of the Sagrada Familia. This is the point where the entire architectural composition of the church converges, and it is also the tallest part of the entire basilica. When completed, the tower will reach a height of 172.5 meters, and at its top stands a massive cross measuring 17 meters in height, covered with glass and ceramic to reflect light. However, constructing a stone tower taller than 170 meters is not a simple task. Engineers must carefully calculate load distribution, control vibrations, and ensure the structure can withstand strong winds at great heights. To solve this challenge, they do not build the tower in the traditional layer-by-layer method from the ground up. but instead divide the entire structure into large stone modules, prefabricated in workshops, and then assembled directly on site. Each panel is essentially a large structural module consisting of 16 stone blocks, precisely cut using CNC machines in the fabrication workshop. The stone blocks are then assembled according to the tower's characteristic curved geometry and connected with hidden steel components inside to enhance stability. Once completed, each panel functions as an independent structural unit capable of bearing loads and transferring forces to the levels below. 8 such panels are assembled to form a complete level of the tower. Thanks to this system, engineers can control the precision of each component before it leaves the workshop. After completion, every panel is inspected for dimensions, tightness of fit, and load-bearing capacity before being transported to the construction site. This modular approach allows most of the work to take place in a safer and more controlled environment compared to direct construction at great heights. At the same time, it significantly reduces construction time, enabling the tower to be erected approximately 16 times faster than traditional stone-by-stone methods. After completion, each panel weighs between 7 and 10 tons and must be lifted to heights of dozens of meters using specialized tower cranes. This process requires precise coordination between the crane operator and the construction team below, because even a small oscillation can misalign the entire component. Therefore, panel lifting is only carried out when wind speeds remain within safe limits. When the panel is positioned, the allowable tolerance is only about 1 millimeter. If the bolt holes are misaligned by even a few millimeters, workers must adjust them directly on site to ensure the panel fits perfectly with the structure below. Throughout this process, every movement is performed slowly and under strict control, with workers continuously observing, signaling, and making adjustments to keep the panel completely stable before final fixation. Only when all connection points are fully tightened and carefully inspected does the panel become a fixed part of the tower, continuing to transfer loads to the levels below. One of the greatest challenges of the project lies in the extremely complex geometry of its columns and stone surfaces. Unlike straight columns in traditional architecture, the columns of the basilica continuously change shape as they rise. A column may begin with a hexagonal cross-section at the base, gradually transform into an octagon, and finally split into multiple branches near the vault, resembling a tree trunk dividing into large limbs. To create stone blocks with such evolving geometry, engineers must combine raw material extraction, advanced machining technology, and refined craftsmanship. First, the process begins with stone extraction at specialized quarries. Large stone blocks are cut from rock faces using modern cutting systems, then transported to workshops as massive raw pieces weighing tens of tons. However, not all stone is suitable. Each block must undergo strict testing for strength, structure, and color to ensure it can withstand heavy loads while maintaining the overall aesthetic consistency of the structure. Next, the stone enters the precision fabrication stage. Based on data from three-dimensional design models, machines cut and shape complex curved and twisting surfaces with extremely high accuracy. Afterward, technicians continue refining and finishing each piece by hand, eliminating even the smallest deviations to ensure that every block fits perfectly during assembly. Thanks to this combination of technology and craftsmanship, a complex stone block can be completed in just a few hours, whereas the same process could take weeks if done entirely by hand. A technical problem began to become more critical than ever for the structure under calculation. For a structure built primarily from natural stone, the challenge is even greater. Stone is very strong under compressive forces, but it lacks flexibility when facing continuous horizontal vibrations, such as strong winds and earthquakes. Therefore, from the modern design stage, the problem of vibration control has become one of the most important factors in completing the central towers of the Sagrada Familia. To address this challenge, a high-strength steel system is integrated inside the stone panels of the tower, acting as a hidden structural framework for the entire construction. Steel bars and steel cables run through each stone module, connecting the panels together in the vertical direction. When these cables are tightened, the stone blocks no longer function as separate elements but are locked into a unified mass. This mechanism creates an effect similar to a monolithic stone structure, but with much greater control over forces. Thanks to the combination of stone and steel, the Sagrada Familia maintains the appearance of a traditional stone church while possessing the load-bearing capacity of a modern engineered structure. Once the space has been opened up by the steel structure, the entire interior experience is now shaped by the stained glass system. Stepping into the Sagrada Familia, what truly transforms this place into an almost surreal experience is light. The entire interior of the basilica is enveloped by a vast stained glass system where sunlight no longer simply enters, but becomes part of the architecture itself. These glass panels are not merely decorative. They are precisely calculated to control how light moves throughout the space. On the eastern side of the church, shades of blue and green are used to create a soft, gentle light in the morning. Meanwhile, the western side employs vibrant reds and oranges, causing the interior to ignite with color as the sun sets. Through this arrangement, the light inside the basilica continuously shifts over time, turning the entire interior into a living canvas of moving light. The windows of the Sagrada Familia themselves had to be designed in a completely different way. Instead of the familiar rectangular openings of traditional architecture, the windows here are shaped based on hyperbolic and parabolic geometries. These curved forms allow light to enter the space more softly and distribute it more evenly throughout the interior. At the same time, they provide an important technical advantage by reducing the load on the stone walls. As a result, the walls of the basilica can be made thinner while still maintaining the strength and structural stability required for the entire building. As light from the stained glass windows spreads throughout the interior, another structure gradually reveals itself, like the framework of the stone forest Gaudí once envisioned. It is a system of 56 massive columns running along the entire length of the basilica, responsible for supporting the vaults and the towers above. Each column is crafted from different types of stone depending on the load it must bear. Smaller columns use lighter materials, while the central columns, those carrying the greatest loads, are made from red porphyry quarried in Iran, one of the hardest and most durable stones ever used in architecture. A single central column alone can tackle up to 6,000 tons of load from the tower above. After more than a century of construction, the Sagrada Familia is finally approaching the most symbolic moment in its history. On February 20th, 2026, the final section of the 17-meter cross will be installed at the top of the Christ Tower, completing the highest point of the basilica. With a height of 172.5 meters, the structure will officially become the tallest church in the world. According to the current plan, the year 2026 marks the completion of the central tower, while the remaining parts of the church will continue to be finished. By around 2033, the entire main structural system of the basilica, including all 18 towers and the vaults, is expected to be completed. After that, the final decorative and sculptural details will be finished by around 2035, bringing to a close a construction journey that has lasted more than 150 years. The Sagrada Familia is one of the very few structures in the world built by multiple generations over more than a century. The first stonemasons who worked on this project in the late 19th century could never have imagined that their descendants would still be continuing the work more than 100 years later. From Gaudí's plaster models to modern structural analysis software and CNC robots capable of cutting stone with millimeter precision, each historical stage has left its mark on this structure. When the final stone is placed around the year 2035, the Sagrada Familia will transition from a construction site that has lasted for centuries into a completed monument. The cranes will disappear, the scaffolding will be removed, and for the first time, the world will see the full vision of Antoni Gaudí exactly as he once imagined. But the final question still remains, is this structure truly worth more than 150 years of waiting? Leave your thoughts in the comments below. And if you want to continue exploring the greatest megastructures in the world, don't forget to subscribe to Mandarin Tech so you won't miss the next videos.